In this video, we are trying to identify what happens when you heat a solid. So first of all, let me tell you what do you mean by a solid is. So I am taking a thin solid for the convenience. It need not be like this, but I am just taking a thin solid. A solid is full of molecules. A material is said to be solid when the molecules are fully occupied and there is no space between them. It is a highly filled kind of a material. There is no gap between the molecules. So assume each circle that I have drawn is a molecule with each one touching the other. There is no gap between the molecules. They are completely filled. Now, what happens when you supply a heat? When you raise the temperature, no molecule in a solid is free to go away from the given place. It is tightly bound with the neighboring molecules. Cannot free to go away from one place to another place because it is attached and strongly bound to the next molecules. What it will do is when it receives energy like a heat energy, it vibrate about its main position, pass the energy to the next particle, and ideally it is supposed to come back to its original position if the molecule is perfectly elastic. But there is nothing like perfectly elastic. Nothing is perfectly elastic. They are somewhere in between perfectly elastic and less than perfectly elastic. So what this molecule will do is it will go transfer the energy to the next particle. It tries to come back, but it couldn't able to come back to its exact position. Thus what happens is between the molecules a gap is formed. Interatomic distance or intermolecular distance increases slightly. Intermolecular distance increases slightly. Thus what happens is when compared with the earlier case, the size of the material, the size of the solid increases a little bit. That small value, whatever is increased, is called as expansion. So the reason for the expansion of a solid is the molecules are unable to come back to their original positions when the external temperature or external heat is gone out to the next molecules. That increase in the gap, that gap generates an expansion. So when heat is applied to a solid, it could expand in multiple possible ways. It can expand, solid can expand along its length. And that kind of expansion is called a linear expansion. It can also expand along its area in two dimensions. That is called areal expansion. It can also expand along its volume. That is called volume expansion. So a solid can expand in three multiple ways: linear expansion, areal expansion, and volume expansion, right? By how much a solid expands, depending on by how much it expands, on two factors initially. Depends on its initial size, like length, area, and volume. Also depends on the nature of that material. If the bonding between the molecules is strong, interatomic distance increases by less, expansion is also less, and vice versa. Thus, if we have to say how much a solid expands, all solids doesn't expand equally. Each solid expands differently, of course in three different dimensions: along the length, along the area, and along the volume. To measure this linear expansion, areal expansion, volume expansion, we do have coefficients of expansions. What is this coefficient of expansion says is, if L1 is the initial length and L2 is the final length, increase in the length is directly proportional to initial length and also directly proportional to change in temperature. If you combine these two, that proportionality can be eliminated with a constant alpha called coefficient of linear expansion. So alpha can be defined as L2 minus L1 by L1 of change in temperature. Its unit is per degree centigrade because increase in the length and length have same units, they will get cancelled. So alpha is a measure of expansion of a wire or a material along its length. Higher the alpha means it expands more and vice versa. Similarly, we can define beta, that is to measure expansion along its area, A2 minus A1 by A1 into delta T, gamma to measure the expansion along its volume. This alpha is called coefficient of linear expansion. Beta is called coefficient of areal expansion. Gamma is called coefficient of volume expansion. There is a relation between this alpha, beta and gamma. We'll derive it in the next video. Thank you for watching.